Hello, today we will be discussing, I will be explaining this problem number 316. And before, uh, I will be explaining this problem in the library of the department's library, while I'm working. So if there are any disturbances, I would like to apologize firsthand. Anyways, continuing on. The problem of 316 is determine the mass of each of the two cylinders if they cause a sag of S equals 0.5 meters when suspended from the rings at A and B. Note that S equals 0 when the cylinders are removed. So the first thing we have to do in this problem is creating a free body diagram of the graph. I have already draw the free body diagram. As you can see here, there's a diagonal here, over here. So what we have to do first is to straighten out that diagonal. And that is by drawing the X and Y graph, similar graph. And in this part, it's TACY and this is TACX. Because we are straightening the CA cord first, the CA spring first. Now, after drawing the free body diagram, we have to draw the right triangles of both of the sides. We don't really have to draw both of them, considering that the values will be the same. So over here, I have already drawn the triangle, and before the stretch, we can see the initial length of the triangle was 1.5 and the width of it is 2. So all we have to do is find the hypotenuse of the triangle and the result is 2.5. After we have already searched for the initial length, then let's move on to after the stretch. The initial length was 1.5, and we already knew from the problem that the sag causes 1.5 meters. So all we have to do is at 0.5, sorry, all we have to do is add 1.5 plus 0.5, and the result is the height after the stretch would be 2, and the length of it is 2. And after finding the hypotenuse of after the stretch, the result will be 2 root of 2. After we have already founded both of the stretches, the initial stretch and after the stretch, we can find the force of the object. The formula of the force is negative constant times x. X can also be the length minus the initial length. All we have to do is plug in the numbers and the result will be 32.8. Now, before we come back to the calculations, we have to, well, for me, I wrote the Newton's law as a reminder. This is just my habit. Why is Fy equals to 0? It's because the state of the object or the springs remains at the same place and there are no motions. There are no motions. Now all we have to do is analyze that both of the ACY and BDY goes to the same direction, meaning that since they are going to the same direction, this sign would be a plus sign. And they would also have to minus it with the weight because there is a weight that goes to the opposite force. Hence why this is a minus. And this is multiplied by 2 because there are 2 weights pulling the springs down. Now, after we have already confirmed the formula, Next thing we need to do is to find the vector components. And as you can see, we have to find the sine and the cosine. How we find this is, in order to find sine, we have to find the front. We have to find the value that is in front of the alpha, and also the diagonal side. Hence why this is 2 over 2 root of 2. And for the cosine, the formula for the cosine is to find the value beside the alpha and also add in the diagonal value. And the cosine is similar. The value of the cosine is similar to the sine. Both of them are 2 over 2 root of 2. When we have already found the vector components, then all we have to do is insert the vector components in this formula. And this is a spring, so that's why it's FAC sine alpha plus FBD co alpha. Oh, and also with the weight formula is m multiplied by gravity, the mass multiplied by gravity. We can plug in gravity with 9.81. That leaves the mass, and we have to find that mass. Once we have plugged in all of the values, we can just calculate it, and after that we can find the mass, which is 2.36 kilograms. That means each of the weight is 2.36 kilograms. That would be all from my explanation. Thank you very much.